Hello. Everyone is here? Okay, I think we can begin. Hello, everyone. My name is Ido Flatow, and this session is all about Fiddler. So first of all, just so I know who I'm standing with here, how many people here actually use Fiddler? Great. How many people here haven't heard of Fiddler? Okay, so do you have a laptop? No? Okay. When you get back home, install and start trying it out. It's a free tool, so I'm not getting anything out of it. In case you haven't met Fiddler before, this is Fiddler, or was Fiddler, back in its earlier days when it was developed for the Office clip-art team. Fiddler was created by this guy, the one on the right, not the one on the left. His name is Eric Lawrence. He worked for Microsoft back in the Office team for clip-art, where he created Fiddler, and then for the Internet Explorer team. Now he works for the company that owns Fiddler, which is Telerik. And this is Fiddler that we have today. Okay, in case you're wondering what Fiddler looks like. I know Eric doesn't like me saying this, but it's obvious that Fiddler was written by a developer because it has no sense of user experience. Sorry, Eric, if you're listening to this, but he knows my opinion. A bit about myself. My name is Ido Flatow. This strange accent is because I come from Israel. I'm a web developer mainly, but I also do a lot of architecture consulting, performance consulting, that sort of things. I do a lot of stuff with ASP.NET for the past 13, 14 years. Wrote several books on the topic, courses for Microsoft, and I also manage the Israeli user group for web development. So if you happen to be in Israel, we meet every third Tuesday of the month, but sessions will be in Hebrew, so I know. I can translate simultaneously if you want. So a bit about Fiddler, just so we'll get to know what this tool allows us to do. So first of all, Fiddler basically, it's a proxy server. Okay, every request you send to a browser goes through that server, and Fiddler just takes that request and pushes it to the server and shows you the response. Okay, just like the old times where we had a proxy server that stores content, this is a proxy server that shows you the content of both requests and responses. Fiddler is a sniffer is able to sniff both HTTP and HTTPS content. This is kind of weird because all this time we thought that HTTPS, that S was supposed to stand for secured. So if it's secured, how come Fiddler can sniff it? So we'll talk exactly how Fiddler does that. Fiddler is not just an HTTP sniffer, it's also an HTTP debugger. Unlike, for example, developer tools where you can just hit F12 and see the entire traffic between your browser and your server, Fiddler can also generate traffic. So it's not only about what it can see, it's also about the traffic that it can generate and can manipulate incoming and outgoing traffic, and we'll talk about that later on. Fiddler is primarily developed in .NET, but today Fiddler has two versions. One in .NET, the other one compiled to Mono, which means Fiddler can run on a Mac and on a Linux. If you don't believe me, as you can see, this is a Mac machine. This is recorded so they can't see the Apple logo I have on my machine, but this is a Mac machine. So let's just turn on Fiddler. Hopefully it will work. Depends on the version of Mono you have installed. Sometimes it causes issues. Let's give it a second. Come on. Second time it usually works. Or it just hangs there. This is Fiddler on the Mac, it just blips. No, it actually works sometimes. It takes it a while to work, and it usually just pops up a message saying enter your MAC credentials because I want to change your proxy configuration. I'm trying to stall some time, but since it doesn't want to work now, try it again in a couple of minutes. It runs so both on the .NET and Mono, so on a Mac. Eventually it will work. It's currently, and hopefully will stay like that, it's a free tool. So you can just go ahead and download it from getfiddler.com. There is a new version just published last week. Eric compiled Fiddler to .NET 4.5. Not sure if it makes any difference, but you can now have it on .NET 4.5 and not only for .NET 4. Oh, took some time. Okay, so here is Fiddler on a Mac. The UI hasn't gotten any better. Okay, and as you can see, it's not getting anything. Let's try something. DevWeek. And for some reason, it's not showing traffic. Capture traffic. Let's do it again. We have 90 minutes of session, so should be enough to get it to work. And if Chrome doesn't work, try Safari. And it doesn't work. Well, we'll give it another try later on. I have to admit, I haven't tested Fiddler for a couple of weeks on my Mac, and I did upgrade my Mono version. I had a couple of months where Mono didn't match Fiddler, and it just didn't load. So hopefully we get around that eventually. So Fiddler is also extensible. It works in .NET. It's written in WinForms, if anyone remembers that platform. And you can also extend it to your own needs. We'll talk about it later, how we do it exactly. I'll show you a component I've written for Fiddler to make my development life a bit easier. Okay, we'll see that later on. And basically, by the way, the last line is not true. It can make coffee. There are coffee machines that can be connected to the internet and receive HTTP messages that say start pouring coffee, so we can just use Fiddler to invoke such HTTP requests. So Fiddler can make coffee, it still can't bring you pizza. Okay, but we're working on it. So how does Fiddler actually work? Fiddler was mainly developed for the Windows operating system, and in the Windows operating system, every type of application, whether it's a C++, .NET, Java, all of those applications use a Windows component called WinHTTP. There's another component called WinINet. And these two components are responsible for sending out HTTP communication into the world. You can, of course, also open a raw TCP socket and send messages. If you do that, Fiddler won't be able to monitor your HTTP traffic, okay, if you're just opening a TCP socket and sending HTTP messages. That's, for example, how Skype is using HTTP. Okay, but if you're using stuff like .NET code, if you're using a browser, Chrome, Safari, Firefox, IE, if you're using Office applications, if you're using most of the applications that were developed for Windows and use WinINet and WinHTTP, Fiddler just configures itself as a proxy server for those two components. So each request you send will be sent through Fiddler to the internet or to the intranet, and the response will be returned through Fiddler to those applications, so Fiddler can show you that content. Okay, so again, the only way you won't be able to see Fiddler is if, for example, you're using an application that opens a raw TCP connection and starts sending HTTP messages on top of it. Or another case, if you are running an application under a different identity. So Fiddler hooks it up as a proxy, but it is only able to hook it up as a proxy to the currently executing user, which is your user which you use to log into the machine. If you're running, for example, a network service, a Windows service, running under network service, local service, that sort of credentials, or if you're using IIS and you have a worker process that runs under a network service or an application pool identity, that is not your user, so it won't be able to see the Fiddler proxy. There are a couple of ways to overcome that. We'll talk about that later on, how to actually sniff those applications. So what are we going to see in the next 80 minutes? Originally, when I started doing this type of session, I went over Fiddler, every one of the menus, every one of the tabs, and showed everything there is to show about Fiddler. But that's too boring. What I want to do is discuss Fiddler by scenarios. I mean, eventually we use Fiddler for a certain scenario. It may be that we use Fiddler to just inspect traffic. Open a website, use Fiddler, and learn everything there is to learn about that website. How many images does it have, what size they are, what kind of JS files it uses, that sort of stuff. We may need Fiddler to do performance tuning. We have an application that we developed, or we like to look at applications other people developed and see how well they perform. Check, for example, if you're using caching properly, if you're compressing messages. We can do that using Fiddler. We might use Fiddler for debugging. Who here develops in ASP.NET or in some kind of a server platform? Most of you, probably, yeah. So you're writing stuff like services, right? Web services, web API, that sort of stuff. We can use Fiddler to create new requests and send them to our services instead of creating a huge client-side application just for testing our services. Okay, so it's very easy to use Fiddler for debugging, and we'll see a couple of examples for that. Testing. Any QA in the audience? Yeah. Okay, so a lot of testers use Fiddler mostly to record messages, because that way it's easy to save those recordings and show them to developers. No, here is the recording, go figure out your bug. But a lot of testers also need to check the messages, for example, to see that the developers configured the caching properly, to verify that there is no bad content or content that we need to hide in the responses, such as, I don't know, comments with swearing and that sort of stuff. And lastly, customers. That's quite strange. I mean, looking at Fiddler, I don't think I'll give it to a customer to use, right? I see that you're all tired after lunch. Okay, I'll try to be more funny than usual. We don't want customers to use Fiddler because, you know, they pull their hair because of our application now, and if we give them Fiddler, they will just stop talking to us. So maybe it's a good idea to give them Fiddler. But there are a couple of things that Fiddler can offer, and we'll see exactly what, that are useful for handling customer issues. Okay? So let's start by talking about traffic and how to inspect it with Fiddler. So first of all, where can we use Fiddler? What type of applications? Basically, everything that has HTTP. It can be a browser application, website, web application, doesn't matter. It can be a desktop application that uses HTTP, for example, I don't know, a WPF or a Java application that sends an HTTP request to a service. It can be a web service that we want to check, so we can use Fiddler to invoke messages and activate that service. It can be all sorts of phone emulators, whether it's the iPhone emulator that I have on my Mac, or an Android emulator, or a Windows Phone emulator. Okay, I can route all the traffic from those emulators to Fiddler just by setting the phone to use Fiddler as a proxy server. And basically, as I just showed you, I can run Fiddler on a Mac if it will just show me the messages. We'll check that later on a Linux machine, on a Windows. And if I have any other device that can't run Fiddler, I can just direct that traffic through Fiddler. So, for example, first demo of today that will actually work. This is a Windows phone, and this is a machine running Fiddler. I've configured this machine, this device, to use this machine as a proxy server. So all I need to do is connect to the Wi-Fi. It's connecting right now. Don't use the internet. I need to use the phone. Okay, so we are connected. Let's open a browser and browse to DevWeek. Okay, and let's go to the speakers page. and see all the photos of the speakers. So we should see the traffic here in a second. Oh, it's probably cached on my phone. Anyone knows how to refresh the cache on a phone? No? Okay, let's try a different page. Let's see the agenda maybe. As you can see, this is working, okay? Browsing the phone, seeing the content in Fiddler. If you are connected, for example, if you have a Wi-Fi at the office, just connect your phone to the Wi-Fi, enter the address of your local machine, and it will, you will be able to see exactly all the content that you browse through the phone, not just the content, by the way, also applications. So for example, if you have applications such as LinkedIn, and of course, most of the applications, how many people here ever developed mobile applications? Okay, so you should know, for example, that for mobile application, we usually use HTTPS, right? And as you can see, I'm also able to collect HTTPS traffic. It's gone now, but let's try and see those things. Okay, so this is an HTTPS traffic, and here is a photo of one of my colleagues. And this is content pulled from the phone. Okay, so no matter which device you're using, a Mac, a Linux, a Windows Phone, Android, and all of devices, iPhones, you can fiddle it with Fiddler. The only thing that you do need to remember to check is go to Tools, go to Fiddler Options, go to Connection, and check this checkbox, which is not checked by default, allow remote computers to connect. That's it. Okay, you'll be able to see all of your devices in Fiddler, and it's very easy to do. Now let me just shut down my Wi-Fi, so you won't have to see this anymore. Okay, so as you've seen just now, there is this list of all requests and responses in Fiddler. This list is called the session list. Please don't confuse it with the session concept that you have in web applications. Okay, this session here means a request and its matching response. There are a couple of things that are shown for each and every one of the sessions. First of all, we have some sort of a sequence and color coding. Again, I don't know what Eric expected, but I don't think anyone ever remembers by heart what each color means. Anyone remembers? I think blue is HTML, right? And green is script or something like that. But I actually don't even remember what each of the things are. So that is why we have, for example, this content column that just tells us which type of request that is, okay? We have information about caching, so this is an easy way to find out if the response is going to be cached in the client or not. This is really good, for example, for testers who want to know exactly what kind of content is going to be cached and thus check the performance of our web application, see if it's actually going to perform as well as we'd like. We have the response size. Everyone who is using web applications on the internet, please check that column. I'm fed up seeing people sending back a 6 megabyte XML file to clients, not file, but a 6 megabyte entity back to the client. Check out the content of your responses. This helps a lot verifying that your application will perform well on the internet after you deploy it to a server and not just on your internet environment. We have a list of processes, so you can see exactly which process caused the request. This is very useful because a lot of time we would like to sort according to the process, or at least clean out some of the processes that we don't want to see. For example, a lot of applications running on your Windows use HTTP connections. Stuff like Dropbox and Twitter clients and that sort of stuff always send a request to the internet to check if there is a new update of some sort. Okay? By filtering out the processes we don't want to see, we can just concentrate on the stuff that we actually want to debug. Oh, sorry. And last but not least, comments. There is an option to specify a comment for each and every one of the lines. Why is that important? So it's not that important if you're going to close Fiddler a minute later, but if you're going to save this content and send it to someone to look at it so they can debug their code and fix the bug. This is a very useful way to just, having your comments in Fiddler instead of giving them the file and writing them a lot of content in your email. Okay? There is also a very nice feature which you can do to attach content to Fiddler, and that is a screenshot. So for example, if you notice, there is a very large toolbar here with many icons, and this icon is a screenshot icon. Just zoom in a bit. Okay? Let me just press it, and let's open a browser here just so we'll see what it does. Oops. 5, 4, 3, 2, smile. Okay. Those who are sitting in the front row might have heard this brief sound. Let's go back to Fiddler, and here is our screenshot. Okay. So you can also create screenshots of, of the error messages that you get while working with the application. Save them in Fiddler, add a comment saying, look at this screenshot. Do you see the bug? Question mark? Yeah, fix it. Okay, and send it to the developer. So one of the most important parts that we have in Fiddler to inspect traffic is a special tab in Fiddler called the Inspector tab. How many people are using the Inspector tab? All of you are using the Inspector tab if you're using Fiddler. It's this tab that shows you the content of the message instead of just a byte string. Okay, so seeing, for example, let's see here, the header and the body of the request, and of course, the header and the body of the response. This is encoded. So there are a couple of inspectors in Fiddler. First of all, we have that row inspector, which everyone uses, that just shows the content of the message. But Fiddler is actually able to look at the content type of the request of the response and show you a matching inspector that will visualize that content. So for example, I'm guessing this is more aimed at the ones sitting in the 2 or 3 front rows. What is this content? Can you identify it? Hint, it says so in the content type. Okay, this is a JSON content. So Fiddler can just show it to you as a JSON tree. Very useful instead, especially in the case that it's not indented. What is this content? Can you identify it? Again, content type. This is an image. So just double-clicking it in Fiddler will show you the image. We all have seen this type of content. This is an XML file. So again, just like JSON, we can see it as an XML. And even for content such as script, JavaScript in this case, I mean, it's indented. I can read that. So why do I need a special inspector from Fiddler? Just because Fiddler has a special syntax view, which will also highlight the text and will show me exactly what's going on. Okay. In addition, by the way, to the syntax view, let me see if I can get that to work. Let's select JavaScript for a second. What did it just do? Okay, I'll immediately tell you how I did that. Let me see if I can see some JavaScript here. This is JSON, this is not JavaScript. Again, let's go to DevWeek. Maybe they have some JavaScript here. Anyone want to volunteer their own website? No, didn't think so. DevWeek doesn't have a JavaScript content. I think it's because it's cached. Let me just delete the cache. Here you go. Google Analytics should be okay. Yeah, okay. So you see this type of content? This is what we call a minified JavaScript file, right? Meaning that best of luck reading that content and understanding what it does. You'll first probably need to copy it to Notepad and start hitting enter just to separate the lines. So one of the things, for example, we can do with syntax view, of course, not just seeing it color-coded, but right-click, format, script, and okay. And now we can start to understand what QC means and what Q means and what M and XC and JA variable mean. But at least we're halfway there to understanding what this code does. Okay, so unminify is also built into the syntax view. Now, by the way, what you saw me doing here, selecting a few of the rows and deleting everything but the rows, just instead of hitting delete button, hit shift delete, and it will delete all the rest. Okay, so that's another good way to work with Fiddler. If you already discussed the session list and tips about the session list, so again in here, if I want to select all of the sessions of a specific type, for example, sent to the same server, of the same type, response type, all of them returning 304, all of the responses that are 200, all of the images, stuff like that, I can also, for example, click this row, but instead of just clicking, press Alt and click on the cell that you want to select, and it will select all the other rows that have the same value in the cell. So for example, I click the name of the host, so it will select all those messages from the same host. If I click the 304, okay, all the 304. And from here to do shift delete, very easy. Okay, so it's very easy now to manage this session list. So the inspectors, we have a lot of inspectors for text, for objects such as JSON and XML, for JavaScript. Anyone here uses WCF? Yeah? So if you ever use WCF, you know that today you have a special binding called net HTTP binding, which serializes the XML as a binary serialization. You can go ahead and download the WCF binary inspector, and it will actually deserialize that XML content and show it to you as standard XML. Okay, that's another thing. And there are all sorts of inspectors here, which we will talk about later on. One of the inspectors, by the way, has made itself into Fiddler itself as a tab. I mean, think of what it took to make it from an inspector to a whole tab, and that is the HTML inspector right here on the tab, on the top. So this is now a tab, but originally it started as an inspector, and I have it just here, the HTML inspector. And what this does is very cool. Let's go to DevWeek again. Anyone here from the DevWeek team, the people who created this website? No, okay. Because I'm going to be do a little criticism here. Let's go and select the HTML page. Okay, so this is the HTML page, all nice and fun. Let's click the HTML inspector. And what this shows us is how much of the website is actually content versus how much of it is white space. And luckily for us, this wasn't written in web forms. Otherwise, the view state would probably be quite large. Okay. So for example, white spaces that take about, how much is it? A fifth of the content. White spaces can also be minified in HTML. Okay, we can have tools that do that. We'll talk about that more when we get to the performance part. So inspectors, one of the cooler things that you have in Fiddler. Comparing, by the way, Fiddler to other network sniffers like Wireshark, Network Monitor, that sort of stuff, those kind of sniffers will only show you the byte array of the traffic. They won't show you the actual representation of that content. Wireshark sometimes identifies images and tells you the size of the image or stuff like that, but won't show you the image. Okay. Now, for Fiddler, one of the things that we often want to see is to check, for example, for stuff which is cached. One of the ways to check if a response was cached or not is by checking, for example, the status code of the response. Okay, so let's do a brief exercise in status codes. Let's see. 404, we'll start with the easy ones. 404, not found. Okay, I like that. 401, this is for the internet developers mostly. 401, unauthorized, right? 304, this is caching. Anyone? Anyone? Never used Fiddler to check cache, eh? Okay, 304 is not modified. This is actually the response. A server will tell you that you have the exact same copy in your cache. Use that. I won't return you the content. Okay. 503. Let's see if you had bugs. 503. Service unavailable. Okay. This happens when you have too many exceptions and your server just shuts down. 500. Come on, you should know this. Yeah. Internal server error. 200. Okay. 301. Yeah, redirect. It's actually 301 is permanent redirect. 302 is a temporary redirect. Anyone knows the difference? Difference is how the browser caches the result. Will it cache it using the original URL or the redirected URL? Just so, for example, if it's moved permanently, there's no point saving in the cache the original URL because we want to go to the redirected URL instead all the time. Okay, so that's how browsers use that information. Okay, so we saw the inspectors, we saw the session list, but the problem with the session list, as we noticed, it gets big over time, both because we see a lot of content from our website and because there are a lot of interferences. Interferences from other applications. For example, how many people here use Visual Studio on a day-to-day basis? Most of you, right? Have you ever seen how much HTTP content Visual Studio makes? For example, when you start to debug, if you're using symbols, then Visual Studio will go to the internet to locate symbols. If you are using TFS or Visual Studio Online or any sort of source control, Visual Studio will always send requests to that source control. It just sends a lot of requests, and it's very hard to debug the application with Fiddler while having Visual Studio running. Okay, so for example, one of the things we might want to do is to filter out processes or addresses such as Visual Studio and our TFS server address. So we can do that using that special tab called filters. So we have a couple of ways to filter that session list. First of all, we can filter it according to a process type. So if we're just checking out the browser to see which request the browser sends, we can just click that area at the bottom, and instead of all, just select browsers. Okay, let me just show you what it looks like by zooming in. Okay, as you can see, this is all processes. You can just choose web browser, and basically it identifies the name of the process, so IE, Chrome, Firefox, Safari, that sort of things. If you happen to name your process chrome.exe, then it probably will appear here. So this is one of the options. Another option is, for example, by a specific process. Okay, you have that little icon here. If you go to Fiddler, click and hold. Let me switch to another window. Okay, oh, sorry. I'll probably need to put it here. Oh, pick a target. And switch here to Visual Studio, then it will now sniff just the process that we've selected. Okay, by the way, depending on the type of the browser you're using, you can actually sniff separate tabs in case each tab has a different process ID. IE, Chrome, Firefox, each of the browser behaves a bit differently when it comes to tabs and processes, but you can try and see if it works. To disable that, to return it to the default, just right-click it, and it will get cleared. Other options of filtering, as I said before, by host or by process. For example, I'm running Outlook on my Windows, and Outlook also uses HTTP a lot. I'm also running Link, the Microsoft Communicator application, and that also uses HTTP a lot. So I just filter out a lot of the Microsoft addresses, stuff like Dropbox addresses that I don't want to sniff, and they will just get automatically removed from the session list. Okay, so you can do that. Let's do, again, a short quiz. In the filters here, we have the ability to filter according to intranet and internet. Can you guess how Fiddler knows if this address is on the intranet or on the internet? Does it check the IP address? Maybe. Does it, I don't know, check the DNS server to see where we resolve the DNS address from? No, it's actually a lot simpler. Intranet address is any name that doesn't have a dot in it. So my dev server 001 is an intranet server, but mydev001.com is an internet server. Okay? So if it's something dot something, it's internet. If not, it's internet. That can also help you if you're doing stuff on the internet and you're probably not using fully qualified names for your servers. So it will be easier to just show only internet hosts and be done with it. Where did this come from? Okay, you can also filter by URL, by status code if you want to make some status codes disappear, like 304, you don't care about the content, you only care about the content, so 304 doesn't provide any content. And you can also do it by MIME type, by size, just show me the larger responses so I'll know if I have any issues. And another one, there is a bar down below that you saw me using. It's this one just here. And anyone ever use that? Anyone? 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 Right? No? No one is using it because no one knows what it is used for. This is actually known as the quick exec role, quick execution, where I can just type commands to manage Fiddler. One of the commands that you saw me use, for example, is the select command. Let's just zoom in here. The select command allows me to type a partial name of a content type, and it will just look for request responses, to be more exact, of that content type, and will automatically select them for me. So if I do select image, it will select all those image/PNG, image/JPEG, and you know, from here to do stuff like shift delete, here are all the images, and if I also want to see all of those images together, I can just click here. This is called the gallery add-in, which allows you to just select a bunch of images and watch them in one location. I can even try and, yeah, this is the one. Right-click and see the exact request. Okay. We'll play with that a little bit more later. So this is filtering in Fiddler. Now let's talk a bit about Fiddler and HTTPS. As I explained, Fiddler is able to catch HTTPS traffic. So although HTTPS is considered secured, it is secured, not just considered secured, okay? Don't worry, it's secured, unless you're using SSL 3, which was broken, so don't use it. HTTPS, or to be more exact, SSL, TLS, the protocol behind HTTPS, is a protocol that is used between two machines. Having Fiddler is like having a third machine in the middle. So basically, when you create a connection between your application and the server while Fiddler is running, you actually create a connection between your application and Fiddler, and Fiddler creates the connection between itself and the server. So what happens actually in HTTPS? In HTTPS, Fiddler connects to that server, sees that server certificate, the name of the server, and then Fiddler, on the fly, creates its own certificate using that server name. Now, I don't know how much you've learned in your work about phishing websites and that sort of stuff. If you create a certificate of your own, no browser will respect it, right? It will show you that error message, the certificate is not trusted, enter this website on your own risk, that sort of stuff. So what Fiddler actually does, the first time you tick that checkbox to enable HTTPS, it will generate a certificate. It's called the root certificate. How many people are familiar with the concept of a root certificate? Root certificate is like the certificate of VeriSign, okay, of VeriSign itself. It creates such a root certificate and installs it in your Windows. You'll see a lot of message boxes asking you, are you sure, are you sure? You'll click yes a bunch of times. It will install the certificate, and then each certificate it will generate will automatically be trusted. So for example, I'm having Fiddler running here, and I already checked that option. It's in Tools, Fiddler Options, HTTPS. I have here both capture HTTPS and decrypt, okay? Once I did that, I can now go to HTTPS sites. And if I check the certificate, you will see that this certificate was issued by Do Not Trust Fiddler Root. Okay, so this is the way you can know that this is actually Fiddler running in the background, giving you its own certificate. And by the way, as I said, this certificate is generated after the installation of Fiddler. It's not that all of the machines in the world that have Fiddler have the same root certificate. Otherwise, that meant that you can just install Fiddler, on every one of the machines and read their content. No, we have to approve installing that certificate. So with Fiddler, you can sniff HTTPS certificate. By the way, to do that on the phone, all I had to do is take the Fiddler certificate and install it on the phone, the root certificate, just so my phone will recognize those Fiddler certificates and will trust them. Otherwise, it would have shown me those messages saying, certificate not trusted, I won't redirect you to that website. Okay? So that's about inspecting traffic. Inspecting traffic is usually just to learn. It's not to actually do anything about it. When we do want to get to the point we actually do something about it, this is usually the point where we use that traffic to check it for stuff like performance. Okay? Next, we'll do bugs, but first let's try with performance because we don't have any bugs. So first of all, as we said before, when you connect using Fiddler, there are actually two connections, one between your application and Fiddler, and the second one between Fiddler and the destination website. So there are two connections, and the other connection, the second one between Fiddler, is actually a connection that Fiddler stores. Okay, it doesn't close the connection every time. It stores it and reuses that connection if you happen to reopen your client and send another connection for Fiddler to the same website. So there is a reuse of connections here, and it's important to understand that because we're going to see that in use. So the first option that we have to actually use Fiddler to check for performance is to use the Fiddler's timeline. Timeline is one of the tabs that we have in Fiddler. It's just here. Where is it? Here? Okay, this is the timeline. And what timeline shows us, it shows us the list of requests over time when each request began, finished, and the subsequent requests that followed it. So again, we have, we have the start time. We have that black bar, which means when the server began to send a response, okay, when we began to get that response, and the end is just the time that we finished getting the response. If you see quite a large area after the black marker, that means that either the response is big or it took a lot of time to get it because of a slow network or stuff like that. If you see a disk icon, if you remember that this is actually a disk, okay? I don't know if all of you were in that era. A disk means that this content has been cached. This is a different way to represent a 304 response. If you see that, that means that there was actually no response. There was a response of size 0. And this is quite logical because you can see those disks. The size after the bar is very, very small. We can see here two icons. They are not quite shown well in the screen. Let me try and zoom in into the slide. Okay, as you can see, there is a red one here and the green one. The green one is not showing just well. So the red one, the top one, means the state of the connection between the client and Fiddler. Red means new. So this basically means that during this request, the client opened a new connection into Fiddler. This happens, for example, in browsers, because browsers open multiple connections when they try to connect to a website. A browser can open, depends on its version and its type, it can open 6 to 8, sometimes to 12, up to 12 connections concurrently. By the way, when using a proxy, some of the browsers will actually open more connections. Chrome uses, if I'm not mistaken, 12 connections when it uses a proxy server, in comparison to 6 or 8 if it doesn't have any proxy configured, such as Fiddler. So the top one is the connection between the client and the server. The bottom one is the connection between the Fiddler application, and the server. Okay, so if you see two reds, this means that this is an entirely new connection that the client opened with Fiddler and Fiddler opened with the server. Probably a new connection altogether. If you see a bottom green, then this is probably a reuse of one of Fiddler's connections. If you see a green on top, that means that both on top and on the bottom, this is an existing connection that the browser just sent another request using that connection. This will help you diagnose, for example, performance issues with servers that don't do keep alive. If you all the time see the connection between Fiddler and your server being red, this means that probably your connection is getting closed after each and every one of the responses. So look at the timeline to verify these issues. Now, one of the biggest things that people don't know about, about Fiddler, other than the colors that no one remembers, is that stripes part, either solid or striped. This shows you if Fiddler is currently buffering the response or is it streaming the response. Now, what's the difference? When Fiddler is installed in your machine, by default, it buffers all the responses and the requests. This is done because you have the ability to catch those messages and change them before sending them back to the browser or sending them to the server. So Fiddler wants to buffer all the content, provide it for functions that it has for you, and then send it to the server and back. But the problem is that this means, for example, if you have a large HTML file that you're downloading for a browser, this means that Fiddler will provide the HTML back to the browser once Fiddler finishes getting it from the network. Unlike, for example, when a browser reads an HTML file, where it starts receiving the HTML, it already starts going over the HTML, recognizing script tags and images, and starts fetching them even before the HTML completes downloading. Okay? Understand the difference between buffering and without buffering? So one of the things that you can do in Fiddler, in the toolbar, there is a button called Stream. This is the first button you want to click when you open Fiddler the first time, and Fiddler actually remembers this setting, so you just have to click it once. Let me show you the difference between the two. So let's clear everything here. Go to DevWeek again. Yeah, let's delete the cache. Let's do this again. Okay. So let's go here to DevWeek and select these couple of lines. So as you can see, I clicked Stream. So as you can see, this is the HTML. And once that HTML is received, I already started to see requests being sent to the server. This is how a browser should behave because I clicked that Stream option, which, again, is not on by default. Now let me turn this off. And this is the default way that Fiddler comes when you install it on your machine. And let me do that again. Let me just close the browser, so we'll do new connections. Oh, cache again. Okay. You see the difference? Okay. The HTML is received. Just after a Fiddler finishes receiving it, it sends it to the browser, and just then the browser starts sending the requests. So do click the stream button immediately after you install Fiddler. That goes for you, the one that doesn't use Fiddler. All of you just turn on Fiddler for once, click that icon, and you're done. Another tab that is very useful for understanding how your, yeah, there was a question. Yeah.
About the cached response, are you able to tell the location of the cache in the server or proxy or client?
The cached response, if I'm able to tell the location where it's supposed to be stored, you're asking? Yeah, I can see that. We'll get to that just in a couple of seconds. Yeah, there's a slide on that. So one of the important parts in Fiddler is the statistics tab. Now, the statistics tab provides us information in two modes. First of all, for a single request, we can see exactly what happened with that request. When the connection was opened between the client and Fiddler, when the connection opened between Fiddler and the server, how much time it took Fiddler to resolve the DNS address of the server, how much time it took it to send the message to the server, how much time it took the server to start responding. We get a lot of information about the timing in each and every one of the requests, so we can deduct a lot of conclusions, such as how much time does it take the server to process the request, how much time does it take to send the request over the network. Okay, that obviously depends on how big it is. So we can check the server time, the execution time of the server. We can deduct those values and get the upload time, how much time it took to actually upload that content to the server. And of course, download time, how much time it took to download it. You can do that manually, or you can just go ahead and you can add those counters at specific execution time in server, download time, upload time. You can add them to the session list as custom columns. The session list itself is customizable, so I can just go ahead and right-click the session list. Let me zoom in a bit. Customize columns, and add session timers that show me all of those stuff. Okay, for example, server think time, overall elapsed, server connected, the different amount of time it took to perform each and every one of the actions as custom columns. And then, of course, I can just sort according to them, filter stuff out, and start to figure out if my application is performing well or not. For multiple items, if I select multiple session, I can get information about how much time it took to process all of those requests, and I can receive some information about the different response codes that I got, and something which is very useful, the different types of responses, images, script files, CSS files, HTML files, and the total size. So again, going back to DevWeek, for example, clear the cache. I remember that now. Let's go to DevWeek. So for example, by browsing the main website, we can see, it's all done, yeah. Statistics. We can see that most of the size of this website is in images, okay? HTML is quite small. Now, if you want to show this to your managers, there's also this option, okay? No managers here, right? Okay. I have no idea what woof2 means. Probably anyone knows what a woof file is? Woof. font. Oh, it's a font file. Okay. Woof. So you can get some statistical information about your website. For example, I tried to check my company's website once. It was about 6 megabytes, out of which 4 was a video file they included in the homepage. Okay. So which kind of other tabs or inspectors do we have that allow us, enable us to do performance testing? So first of all, someone asked here from the audience about caching. There's a special tab called caching that looks at the response and gives you information about the caching header. There are plenty of caching headers. There's a date, and there's max age, and expires, and e-tags, and all sorts of caching headers. This tab will try and make sense out of all of that information. So if we go to inspectors, to the caching headers, I specifically selected an image because it's supposed to be cached from what I saw. So as you can see, this one has an e-tag header. It says that the last modified header is up to February 15, presented by February 15, 2015, which means it was created about a month ago. Let's see, you asked about proxies. Okay, so this one is public, so the response may be cached by any cache, CDN, proxy server, that sort of things. Max age currently specified that this will expire in about 10 years, 3,650 days. They probably don't know that according to HTTP rules, you're not supposed to set the max age to more than a year. Just saying, okay? Browsers should usually ignore this setting and will just set it to the maximize they are allowed to, which is 1 year from now. So as you can see, it takes that max age value, which is in seconds, let's see that in the headers, and will just transform it to you and give it to you in days, in minutes, in seconds, that sort of things. So this is the caching tab. Okay, just take that entire set of information and provide some textual information about it. Some other things, the image view. As we saw that, we can see images in the website, but not only images. We can actually see stuff about that image. So let's try and select a big image. Let's see according to the size. This is a big image. Yeah, makes sense. So what we can see about that image, for example, is if it has any more additional data. From what I can see here, it doesn't have any additional data. Let's try some other stuff. Here you go. Let's see what's in here. Not that much. Sometimes what happens, for example, here you go. When you use a professional image editor, such as Photoshop and stuff like that, those applications put a lot of metadata in the file. What Fiddler allows you to do is, first of all, look at that metadata, and it shows you exactly how big that metadata is. So for this small icon, the metadata file, the metadata content is 14K, which is 80% of the file. Just saying, maybe consider removing the metadata. There are applications that can strip it away. You can also, let me see if I can. I don't have that application here. There is also a plugin that you can download that what it does, it just takes those images, processes them when they are returned in the response, and shows you in the web page itself, just underneath the image, the size of that image and if it has a lot of metadata or not. This is a plugin created by Eric, the creator of Fiddler, to help people understand if they're using photos that can be compressed, can be shrunken and left the metadata out and stuff like that. Okay, so this is the image view and the cool stuff that it can show you. In addition, stuff like the transformer. How many people actually know if their content is being compressed or not? 1, 2, 3, right? There are plenty of people here in the crowd. There is a very easy way to know if your content is being gzipped or not. Just go to Fiddler, and of course, for images, that won't be useful because images are usually not compressed, at least not by web servers. They're compressed by the themselves. Let's browse again. Okay, and let's select, for example, the HTML for DevWeek. As you can see, it says here, response is encoded and may require decoding. I'm not sure if it's encoded because it's compressed or because it's chunked. Chunked is the streaming mechanism of HTTP. So I can just click on the transformer tab to see exactly what happened to this message. So this one is both chunked and gzipped. If you look at the raw content currently without encoding, you'll actually see that this one, as you can see, let's remove the truncate. Okay, this is compressed, of course, but you can also see the size here that says the size of the chunk. This is, of course, in hexa. I can't see the real size of the message here because for chunk data, I don't have a content length header, but I can see that in the transformer, it's currently 5K. Now, if I undo the chunk, it will be a bit smaller because I don't have those values in the body that says here's a chunk that is 100 bytes. But if I remove the compression, I can also see how much I actually saved by having this page compressed. Okay, so that was about 5%, right, of the original value, 5 out of 20. So you can actually also take, for example, pages that are not compressed. For example, this page is not compressed. And if you want to see how much you could have saved by taking this file and compressing it, just click the gzip. Let's hope for the best. Not that much, okay? But for example, for HTML files, JavaScript files, this is probably not a text file. Let's see the content. Yeah, this is that woof font. JavaScript, for example, I'm guessing this one is compressed, yeah. Compressing a JavaScript file, as you can see, can do the reduction by half, sometimes by even 70%. So look out for the ones that are not compressed. You can even filter them out. Just leave me the ones that are not compressed, those that don't have that special header that is called, where is that? Let's select one that is compressed. Content type, where's the content type? Content type. Content type. Not content type, sorry, content encoding. Content encoding. It's supposed to be here somewhere. Gzip headers. Okay, look for that content encoding. Here you go. And if it says gzip, if it exists in any way, that means that the content is encoded, it's compressed. If it's gzip or deflate or something else, you can just notice this here. Okay, so you can also filter out the stuff that are not compressed to find out what you compress or not. Yes?
Can you use it to examine motion JPEG, for example, if it was been streamed over multi-part network?
If a JPEG has been streamed or not? Basically, yes. The streaming in HTTP is that chunked encoding that I showed. So if the transformer says it's been chunked, then it's probably been streamed in some way. I'm not sure if the browser actually showed it, loading pixel by pixel, but it has been streamed by the server. That now depends on what the client application did with that data.
But can you, for example, like the way Wireshark works, can you start up the browser which streams motion JPEG, run it for 10 seconds, stop it, and examine everything which is captured?
No, you can't. Yeah. The question is, can you just, like Wireshark, open Fiddler and inspect the traffic coming in byte by byte? It's possible in some way. For example, if this actually takes a lot of time to work, Fiddler doesn't have to wait until it receives the entire message for it to show you, especially when it's chunked. So how many people are using chunked content or think that they're using chunked content or hope that they are using chunked content? Yeah, most of you hope. So what you can do is if you see that this message is currently still downloading, okay, you don't see the response, the response code, just right-click it, and there is an option here saying Comet Pick. Comet Pick will actually show you the current data that that message is currently holding, and it's intended for chunk content. Okay? So only if it's chunked, it will show you the current bits that it has. Last one, HTML inspector, already showed it to you, allows you to get information about your HTML, if it has been minified or not. If you see a large view state, that means you're probably a web form developer, and you should switch to MVC. If you see a lot of white spaces, just go ahead and remove all of those enter tabs. They don't affect the HTML. They're mainly for you, okay? So to draw conclusions about this stuff, stuff like reducing number of requests, if you see a lot of requests in Fiddler. We use Fiddler to figure out if you have too many round trips, get something from the server, do something, get something again. We can see web service calls like that. Remove size of requests and responses by applying stuff like compression, applying caching rules where needed. All those stuff we can learn from Fiddler. The most important thing is don't use Fiddler to measure the traffic, okay? To measure the latency, because Fiddler is a proxy server. Fiddler will actually open a connection and we get the information back. It opens a certain number of threads in order to do that. It may lower the performance. By the way, it may also increase the performance, because when Fiddler is turned on, it's a proxy, so the browser will actually use more concurrent connections than without a proxy. Okay? So it really depends on how it will be used. So use it to look at the timeline and at the statistics, but not to do load test and figure out how much time it actually takes to send the request and get the response. Next scenario, debugging. So first of all, for debugging, as I mentioned before, instead of just sniffing the traffic, looking at the traffic itself, the request and the response, we can actually change stuff in the message by using Fiddler. So Fiddler has built-in features, for example, to change the user agent that is sent. If your application is sensitive to the user agent, if for mobile devices it shows different content, if your load balancer, you want to test it, if it switches traffic between regular users and bots, like Google bot, and directs, for example, search engines to a different location. A lot of companies are doing that because bots have a lot of, make a lot of load on a system when they scan it. So you can detect in a load balancer if it's from a bot according to the user agent and direct it to a certain machine that will only serve bots. So you can actually check that using Fiddler and mimic a bot. You can also do stuff like disable caching headers. You can also remap hosts files. How many people are editing the host files? I'm guessing testers do that often. Hosts file is the file that allows you to remap DNS names into IPs. For example, if you're using the production machine now and you want to use the same URL but point to a test machine, you can just open the hosts file. It's under C, Windows, System32, etc, drivers, etc. And you can just say my server name, the new IP that it should get, and from now on, your machine will return that IP instead of the original IP. Instead of doing that manually, you sometimes want to do that only when you're debugging. So just go to Fiddler, open Tools, Hosts. As you can see, I'm already using that. And first of all, it can import your hosts file from Windows. And second of all, you can just place here your own servers. And as you can see, unlike the hosts file, where it has to be DNS and IP, the DNS you're browsing to and the IP that it gives you back, here you can have a DNS and also a DNS. It doesn't have to be an IP. Okay, so I can say if I'm browsing to local.idoflato.net, please give me localhost. Okay, it doesn't have to be an IP address. It doesn't have to be 127.0.0.1. So what other ways do we have when debugging? How many people can relate to the following scenario? I'm creating a web application. I've created stuff in MVC or web forms, doesn't matter. I'm running my client application, going through the input fields, entering everything. Maybe it's even a few on your next, a wizard style. Click submit, save, whatever. It runs, and then I get an error message. Something happened. I'm saying to myself, oh, yeah, I forgot it's not less than, it's less or equal than. Going to the code, changing the code, recompiling, going back to my application, and then redoing everything again, right? But nothing has changed on the client side. Nothing has changed in regards to the request that I'm sending to the server. So why not just use Fiddler and get Fiddler just to reissue the same request? The response will change, hopefully. But at least I will be able to see if the bug is still there or not. So if I do have a request, the easiest way for me to do this is just right-click, replay, and click reissue request. There's even a simpler way to do that. There's a button for that. So I can just click it. I can also click it a bunch of times. If you want to load test your system, you can even press Shift and click it and say, let's do this 100 times. Okay? This will really stress your system. Don't try this with online websites. You may get blocked out of the website. Depends. I tried it in a forum website once while doing a demo in my company, and my company was blacklisted for a couple of hours from getting to the website. That wasn't 100 calls. That was, I think, 1,000 calls. So this is called reissue or replay. You can do a bunch of stuff with it. You can just click and replay. You can tell Fiddler to replay without the caching headers. Why would I need that? For example, if I got a 304 response from the server, that means that, let's see that here. I'm guessing that I can. Let's see if I got, do I have a 304? Oh, 304 here. Back to DevWeek. No 304. Let's go to stuff like, no 304 because I cleared my cache. Let's try it again. Here you go. Stop. You see this response? This didn't return any content, not modified, but I do want to see the content. So just right-click, replay, and in here you have the option of unconditionally. So before doing that, let's just clear all the other requests. Replay unconditionally, and here you go, and you can see the content. Okay, sending the same request just without all the headers, the caching headers at least. Okay. Another thing that you can do is actually edit that message before sending it to the server. So if you've posted something and you find out that you made a mistake, you can just take that JSON that you posted or that XML, open it in a special editor called Composer in Fiddler, edit either the header or the body, and send that again. So for example, I don't have any post requests here, but let's take that Composer. And I think I actually have a history of post requests. This is a new feature in Fiddler, by the way, a list of requests that you already sent to the server using that feature. Here you go. This is a post request that I have. I can just grab that request, change the headers, change the body. It will automatically calculate the content length, so I don't need to count the number of characters. Just execute that. I'm not sure if it will work because it's going to my S-Express, which is not turned on right now. But I will just get the response here, double-click it, and it will show you the response. Okay, currently, of course, I don't have the server turned on. So we can just grab a request, drag it here, and it will allow you to resend that request, but allow you to, first of all, change this request. Of course, this is currently grayed out because this is a GET request, not a POST request. Now we can edit that. Also upload the file. Also do other stuff, for example. Try to look for a URL of that sort, but I couldn't find any, so let's try maybe this one. So let's look at this one, for example. I'm not sure if it will work. Should work. It's my IIS, and it's turned on. So this is just a website that I'm actually going to show tomorrow in a workshop that I'm doing here. Should take a minute or two, not minute, sorry, a second or two for the website to start. Here you go. You can see here the response. Now let's drag that back to the composer. Can actually do the following. Now, look closely. £, lower value, 10, upper value, 20, and if you have any kind of websites that have in the URL a part which is a number, you can just tell Fiddler, well, just scan through the numbers and give him the results, okay? You can do that on online dating sites, forum pages. You know, you go ahead and think of where it can be used. Yes, there's a question.
The new option you had on the right to replay previous requests.
Yeah, replay.
Does that get reset when you restart Fiddler?
No. I actually, this list is a list that remembers your previous usage from times you even closed Fiddler. Yeah, so I can close it, reopen it. You can even have a scratch pad here where you can save stuff that you want over time, important stuff, and I can just mark them and call execute. Okay? And for the important things that you need, such as clear my server cache, if you're debugging a .NET application, maybe a request to do a GC collect before grabbing a memory dump, you can just have your usual messages set here in the scratch pad and then reissue them by selecting them. Easy as that.
So you say it's new, is that already available?
Yeah, it's available. It's from a couple of months ago. Yeah. New in my perspective is, since 2015. Okay. Another thing that we have in Fiddler is the ability to place breakpoints. I can actually stop the response in Fiddler and change it before sending it back to my client, which is a very nice thing. For example, if you want to plant an error in the message, but you can't edit the server, right? So I can do that in Fiddler. I can also set, instead of manually editing this stuff, I can choose out of a set of existing responses. So for example, if I want to go ahead and say in my, sorry, where was I? So yeah, breakpoint. If I want to issue a breakpoint, let's turn that back on. We can even, here you go. This is a request that was issued right now. This is the request. This is the response. The response is for an image. I can now respond with, for example, 404. Where is it? Don't have a 404. Not modified. Okay. Respond with not modified. Run to completion and see how the application handled this response. So, for example, I can check if my client applications can handle HTTP 500 without crashing. I can check how my application manages to handle 404. Maybe even issue a file. Let me just turn this off. You can turn it on either by clicking here in this area. This is outgoing request. This is incoming response. Or just by rules, automatic breakpoints, and you have them here. And I can even issue a specific file where whenever this breakpoint is stopped. Another issue that we have in Fiddler, it's not an issue anymore, but it was an issue a lot of years ago, is debugging localhost communication. How many people had issues debugging localhost communication? It's mainly when we used Fiddler back in 2010, 2011. At some point, Microsoft had a fix in Windows that allows Fiddler to hook up even when we call localhost addresses, 127.0.0.1. But sometimes, for example, if you use .NET and you call into a localhost address, you won't see it in Fiddler. That's because .NET is a sneaky little guy. What they do is they actually check the address you're trying to call, and they try to check if it's localhost or not. And if it's localhost, they bypass the proxy configuration. So one option that you have is change the proxy configuration and force that proxy in .NET. but that requires changing the code, maybe changing the configuration. What you can do is you can just change the address. So first of all, use the machine name instead of localhost. This usually works. It won't work if your server is specifically listening on 127.0.0.1, because that way it will require that you use that same IP address. So you can also use fictitious addresses. So for example, if you're listening on 127.0.0.1, you can change the address you're using to IPv4.fiddler. IPv4.fiddler is an invented address. .NET doesn't know what IPv4.fiddler means, so it will think it's an internet address and will try to connect to it. Fiddler will catch that message, see that IPv4.fiddler, and it will recognize that address, and it will replace it with localhost. Or to be more exact, it will replace it with 127.0.0.1. If you wanted to replace it with localhost, just use localhost.fiddler. Okay? And it does that for you. Simple as that. So if you're using, for example, IIS Express, anyone using IIS Express? IIS Express doesn't use your machine name. It uses localhost or 127.0.0.1. So you can't call it using your machine name. So use either localhost.fiddler or IPv4, IPv6.fiddler. Okay, we'll actually see that in a second. So I mentioned this before. If you're using Fiddler, but, bless you, if you're using Fiddler but not with an application that you're currently running under your username, but an application that is running as a Windows service or in IIS, you have a problem because Fiddler can't hook up its proxy settings to that application. What you can do, you can actually run Fiddler under a different identity. So you can use a tool from sysinternals called psexec. You can just go online and download that. And you can tell that tool, please run Fiddler, but under the credentials of, say, network service. It will open the Fiddler application. That's why we have that -i. It's interactive. It will open the Fiddler application. But if you look, for example, at the task manager, you'll see that Fiddler is currently running as network service. And it will catch all the network service communication, which is used, for example, in IIS, in Windows services, and such. Just close that, open Fiddler on your own, and it will be back under your username. Don't open it twice, okay? Because otherwise you have two applications trying to listen on port 8888, and they will collide. Now, how many people ever seen this message? Or this message? Or the unfortunate this message? Can you recognize the difference, by the way, between these messages? These messages appear when Fiddler crashes and it's not able to remove itself as a proxy server. That means that your applications are actually trying to communicate to the internet through a proxy server that is not online. And they will get an error saying that, unable to connect to proxy server. If you're using Firefox or Chrome, if you're using IE, you'll just get a message, IE cannot display the web page. Is it a Wi-Fi problem? Is it my ISP? Is it my computer? Let's try to restart. Basic thing that you should try if you're using Fiddler on a day-to-day basis, just try opening Fiddler, closing it. This will reset the proxy settings. I have a funny story about this. I showed this once in a workshop that I did on Fiddler, and somebody came to me and told me that IT didn't know what his problem was, and they actually formatted his machine because of it. Because restart doesn't help if your proxy settings are not configured properly. So they tried resetting the Wi-Fi, hooking him up using an Ethernet connection. Nothing worked. They formatted his machine. Just open Fiddler, close Fiddler. Usually it works. Okay. Last one, almost last one. Testing. How much time do we have? We have 10 minutes? Yeah, 5 minutes. That should be enough. People actually use Fiddler when they are testing the application. We have a QA here in the crowd that can tell us that this is the case. Now, a lot of time when we test our application, not necessarily we're the one who wrote the code. So it doesn't help if we see the error in Fiddler. We want the actual developer to see that error that we got. This is why Fiddler allows us to take that session list and store it as a file. We can just take that file, send it via email, open it on a second machine, it will open Fiddler and will show us that exact content, including all the timing information, including the DNS lookup and the TCP stuff, everything else. We will be able to see exactly the same content, including those screenshots I showed it to you earlier. So just go to Fiddler, click File, Save, All Sessions, choose whether you want a session archive or password protected if you're working on a sensitive application and you don't want to save all that content unencrypted. And just send it over to someone who knows what they're doing. And since you're all interested in the list of reasons, here's a zoom in to that. I mostly like, which is mine, 19 is usually what I use. What else? 8 is the lazy programmer's excuse. Each and every one of you can relate to this, I'm guessing. Another one of the things that you can do with Fiddler is to have it auto-respond to some of your requests. So, for example, if you know that one of your services is going to be shut down due to maintenance, but you want to be able to keep on using the system, you can actually record a session against that service and just tell Fiddler, every time you see a request that looks like so, please respond with this specific content. Okay? So I can respond, for example, with stuff like, with a redirect, with a breakpoint, for example, if I want to break just in case something happens. I can also respond with a file. Let me show you an example of that. Let me just turn on a response that I have here. And let's browse DevWeek again. So I recorded all the requests coming in, going out, for getting images of speakers, and I asked it to, asked Fiddler to return a specific image instead of the image it's going to get from the server. So what I can do is just click here and enjoy myself. Okay. As you can see, these lines are now marked because what happened is that it matched the following URL, and I responded with a fixed image, which is, of course, my own. Okay, so you can actually go ahead and record websites like that. I sometimes use a recording of my company's website, so I can show our website to people even if I don't have an internet connection. It's very easy to do that unless you're using Chrome, which actually checks if you're connected to the internet or not. I think I closed Fiddler. Why did I close Fiddler? We're not done with the session yet. Okay. Lastly, but not least, customers. So first of all, if you can't install Fiddler on a customer machine because you need to diagnose something, you can install Fiddler on the server. Fiddler can actually act as a reverse proxy, meaning that it will listen on port 80 and not your web server. It will redirect all the incoming traffic to a different port that you set for a web server, say 81 or 82, and then it will send back the response. So it will be your web server, okay, and act as a reverse proxy so you can see all the data coming in from your clients. If you go to this link, it will show you exactly how to do that. It requires some registration, registry configuration, and that's basically it, just running one simple thing, in the application. Another tool that you can use, and that's what I said about using Fiddler in a customer's machine. There is another tool in addition to Fiddler called Fiddler Cap, short for Fiddler Capture. This is Fiddler Cap. What you can do in some very brief steps, you install that, just give it to your client and tell them to install it and run it. You click button number 1. It's grayed out. It's here. A browser will open, tell your end user to browse the website. This tool will record the sessions. It will not show the session list. I press this button here just to show you the screenshot, but basically what it does, let's go to Fiddler Cap here. Okay, this is what it does. Start capture. Get back to the tool. It captured 10 sessions because of the cache. Okay. You can take screenshots using the button here. Snapshots. Okay, let's put it here for the recording. Click Stop Capture. Click Save. Actually should offer some usability improvement to do 3 and 2 together. Stop and save. I mean, why will it stop if not to save? And ask your end user to email the SAZ file to you. It's the same SAZ file as you get with Fiddler, and that's a whole lot nicer than using Fiddler, at least for an end user. Okay, it will create the same type of message, and you even have a button here to clear cache, clear cookies, that sort of stuff. Okay. So, one last thing about extending Fiddler. Fiddler is written in .NET. It has a lot of extension points. You can add menus. You can add toolbars. You can add inspectors. You can add stuff that manage the quick exec. You can add new commands to it if you want to type in something that will do wonderful things in Fiddler. Can't figure out what, but wonderful things. You can create your own export and import system if you want another format for Fiddler to support. Okay. I, for example, created an inspector that shows me encoded values in my messages and decrypt them, not decrypt, but decode them to show me their content. So let me just show it to you before we conclude. So, for example, how many people know what a JWT token is? How many people ever heard of OAuth, Open Authorization? Yeah. So this is an application that uses OAuth in order to send information to my machine. So let's do this. Wait a minute. Fiddler is not turned on. Yeah. Let's close that. Fiddler. So I'm identifying against a server. Should see the information now in Fiddler. Give it a second. Okay. I was able to authenticate against my server, and as a result, I got this large token that contains information about my user, my client user. That's going to my server, and that will allow the server to authenticate me. So I created an inspector to open this token and show me exactly what's written in it, almost what's written in it, not the entire token. And this is what's in the token, okay? Information about myself, my user. This information I got from an Active Directory machine. So here is the list of the groups that I belong to, and my unique name in the Active Directory, and other stuff that I needed to debug, okay? If I didn't write this inspector for myself, I would end up placing a breakpoint in Visual Studio and going there every time and watch my user objects and checking claims and that sort of stuff. And in here, I can do it quite easily without the need of Visual Studio. Okay, so come on. PowerPoint on a Mac. So Fiddler is more than just a sniffer. Yeah, it's able to monitor traffic, but you can do a whole lot of things with it to debug your web application, to figure out how it performs, to easily test stuff, to exchange information between developers on how your application works. And it's also extensible, so you can add the stuff that you need to Fiddler, okay? So I'm very pleased that all of you, except one, have already have Fiddler on their machines. You install it by tomorrow, okay, I'll check. I'm here for tomorrow also. And for the rest of you, if you want to learn more about Fiddler, I talked to Eric, the creator of Fiddler, and he gave me a link to give you for a 50% off for the Fiddler ebook. If you want to buy a book about Fiddler, it's just been updated to the latest release of Fiddler. So you can just go to that link and get a 50% off. This presentation is already online if you want to go and check it again. The Fiddler website is here. The forum, Eric is listening all the time and is answering any type of questions you'll have, unless it's a really silly question, and in this case, he will tell you, go buy the book. There's also the blog for Fiddler, where they post the new stuff that they publish, and my information, if you want to pick my brain about Fiddler, stuff that you saw there, or just, say hi. Thank you very much for coming. Enjoy the rest of the conference. Hello. Everyone is here? Okay, I think we can begin. Hello, everyone. My name is Ido Flatow, and this session is all about Fiddler. So first of all, just so I know who I'm standing with here, how many people here actually use Fiddler? Great. How many people here haven't heard of Fiddler? Okay, so do you have a laptop? No? Okay. When you get back home, install and start trying it out. It's a free tool, so I'm not getting anything out of it. In case you haven't met Fiddler before, this is Fiddler, or was Fiddler, back in its earlier days when it was developed for the Office clipart team. Fiddler was created by this guy, the one on the right, not the one on the left. His name is Eric Lawrence. He worked for Microsoft back in the Office team for clipart, where he created Fiddler, and then for the Internet Explorer team. Now he works for the company that owns Fiddler, which is Telerik. And this is Fiddler that we have today. Okay, in case you are wondering what Fiddler looks like. I know Eric doesn't like me saying this, but it's obvious that Fiddler was written by a developer because it has no sense of user experience. Sorry, Eric, if you're listening to this, but he knows my opinion. A bit about myself. My name is Ido Flatow. This strange accent is because I come from Israel. I'm a web developer mainly, but I also do a lot of architecture consulting, performance consulting, that sort of things. I do a lot of stuff with ASP.NET for the past 13, 14 years. Wrote several books on the topic, courses for Microsoft, and I also manage the Israeli user group for web development. So if you happen to be in Israel, we meet every third Tuesday of the month, but sessions will be in Hebrew, so I know. I can translate simultaneously if you want. So a bit about Fiddler, just so we'll get to know what this tool allows us to do. So first of all, Fiddler basically, it's a proxy server of application, whether it's a C++, .NET, Java. All of those applications use a Windows component called WinHTTP. There's another component called WinINet. And these two components are responsible for sending out HTTP communication into the world. You can, of course, also open a raw TCP socket and send messages. If you do that, Fiddler won't be able to monitor your HTTP traffic, okay, if you're just opening a TCP socket and sending HTTP messages. That's, for example, how Skype is using HTTP, okay? But if you're using stuff like .NET code, if you're using a browser, Chrome, Safari, Firefox, IE, if you're using Office applications, if you're using most of the applications that were developed for Windows and use WinINet and WinHTTP, Fiddler just configures itself as a proxy server for those two components. So each request you send will be sent through Fiddler to the internet or to the intranet, and the response will be returned through Fiddler to those applications, so Fiddler can show you that content. Okay, so again, the only way you won't be able to see Fiddler is if, for example, you're using an application that opens a raw TCP connection and starts sending HTTP messages on top of it. Or another case, if you are running an application under a different identity. So Fiddler hooks it up as a proxy, but it is only able to hook it up as a proxy to the currently executing user, which is your user which you use to log into the machine. If you're running, for example, a network service, a Windows service, running under network service, local service, that sort of credentials, or if you're using IIS and you have a worker process that runs under a network service or an application pool identity, that is not your user, so it won't be able to see the Fiddler proxy. There are a couple of ways to overcome that. We'll talk about that later on, how to actually sniff those applications. So what are we going to see in the next 80 minutes? Originally, when I started doing this type of session, I went over Fiddler, every one of the menus, every one of the tabs, and showed everything there is to show about Fiddler. But that's too boring. What I want to do is discuss Fiddler by scenarios. I mean, eventually we use Fiddler for a certain scenario. It may be that we use Fiddler to just inspect traffic. Open a website, one also on a Mac. Eventually it will work. It's currently, and hopefully will stay like that, it's a free tool. So you can just go ahead and download it from getfiddler.com. There is a new version just published last week. Eric compiled Fiddler to .NET 4.5. Not sure if it makes any difference, but you can now have it on .NET 4.5 and not only for .NET 4. Oh, took some time. Okay, so here is Fiddler on a Mac. The UI hasn't gotten any better. Okay, and as you can see, it's not getting anything. Let's try something. DevWeek. And for some reason, it's not showing traffic. Capture traffic. Let's do it again. We have 90 minutes of session, so should be enough to get it to work. And if Chrome doesn't work, try Safari. And it doesn't work. Well, we'll give it another try later on. I have to admit, I haven't tested Fiddler for a couple of weeks on my Mac, and I did upgrade my Mono version. I had a couple of months where Mono didn't match Fiddler, and it just didn't load. So hopefully we get around that eventually. So Fiddler is also extensible. It works in .NET. It's written in WinForms, if anyone remembers that platform. And you can also extend it to your own needs. We'll talk about it later, how we do it exactly. I'll show you a component I've written for Fiddler to make my development life a bit easier. Okay, we'll see that later on. And basically, by the way, the last line is not true. It can make coffee. There are coffee machines that can be connected to the internet and receive HTTP messages that say start pouring coffee, so we can just use Fiddler to invoke such HTTP requests. So Fiddler can make coffee, it still can't bring you pizza. Okay, but we're working on it. So how does Fiddler actually work? Fiddler was mainly developed for the Windows operating system. And in the Windows operating system, every type of, every request you send to a browser goes through that server, and Fiddler just takes that request and pushes it to the server and shows you the response. Okay, just like the old times where we had a proxy server that stores content, this is a proxy server that shows you the content of both requests and responses. Fiddler is a sniffer is able to sniff both HTTP and HTTPS content. This is kind of weird because all this time we thought that HTTPS, that S was supposed to stand for secured. So if it's secured, how come Fiddler can sniff it? So we'll talk exactly how Fiddler does that. Fiddler is not just an HTTP sniffer, it's also an HTTP debugger. Unlike, for example, developer tools where you can just hit F12 and see the entire traffic between your browser and your server, Fiddler can also generate traffic. So it's not only about what it can see, it's also about the traffic that it can generate and can manipulate incoming and outgoing traffic, and we'll talk about that later on. Fiddler is primarily developed in .NET, but today Fiddler has two versions. One in .NET, the other one compiled to Mono, which means Fiddler can run on a Mac and on a Linux. If you don't believe me, as you can see, this is a Mac machine. This is recorded so they can't see the Apple logo I have on my machine, but this is a Mac machine. So let's just turn on Fiddler. Hopefully it will work. Depends on the version of Mono you have installed. Sometimes it causes issues. Let's give it a second. Come on. Second time it usually works. Or it just hangs there. This is Fiddler on the Mac, it just blips. No, it actually works sometimes. It takes it a while to work, and it usually just pops up a message saying, enter your Mac credentials because I want to change your proxy configuration. I'm trying to stall some time, but since it doesn't want to work now, try it again in a couple of minutes. It runs so both on the .NET and use Fiddler and learn everything there is to learn about that website. How many images does it have? What size they are? What kind of JS files it uses? That sort of stuff. We may need Fiddler to do performance tuning. We have an application that we developed, or we like to look at applications other people developed and see how well they perform. Check, for example, if you're using caching properly, if you're compressing messages. We can do that using Fiddler. We might use Fiddler for debugging. Who here develops in ASP.NET or in some kind of a server platform? Most of you, probably, yeah. So you're writing stuff like services, right? Web services, web API, that sort of stuff. We can use Fiddler to create new requests and send them to our services instead of creating a huge client-side application just for testing our services. Okay, so it's very easy to use Fiddler for debugging, and we'll see a couple of examples for that. Testing. Any QA in the audience? Yeah. Okay, so a lot of testers use Fiddler mostly to record messages, because that way it's easy to save those recordings and show them to developers. No, here is the recording, go figure out your bug. But a lot of testers also need to check the messages, for example, to see that the developers configured the caching properly, to verify that there is no bad content or content that we need to hide in the responses, such as, I don't know, comments with swearing and that sort of stuff. And lastly, customers. That's quite strange. I mean, looking at Fiddler, I don't think I'll give it to a customer to use, right? I see that you're all tired after lunch. Okay, I'll try to be more funny than usual. We don't want customers to use Fiddler because, you know, they pull their hair because of our application now, and if we give them Fiddler, they will just stop talking to us. So maybe it's a good idea to give them Fiddler. But there are a couple of things that Fiddler can offer, and we'll see exactly what, that are useful for handling customer issues. Okay? So let's start by talking about traffic and how to inspect it with Fiddler. So first of all, where can we use Fiddler? What type of applications? Basically, everything that has HTTP. It can be a browser application, website, web application, doesn't matter. It can be a desktop application that uses